Yo, welcome back. Today's lesson, introducing proportional relationships with tables. So this is, you're graduating, okay? You're graduating from simple multiplication to the next stage of development, which is proportional language, okay? It says here, notice and wonder, paper towels by the case. Here's a table that shows how many rolls of paper towels a store receives when they order different numbers of cases. All right, what do you notice? Take a moment to do that. All right, so hopefully you notice that each of these is multiplied by 12. All right, and that 12 right here would be the constant, okay? And I'm going to explain this in more depth, but I'm just going to give you some foundational concepts or definitions, okay? So the proportional rule, okay? Well, let me just say this. Something is proportional equals, and we're talking about proportional, equals, just to keep the note simple, two constants, two quantities rather, two quantities, okay, two quantities or two things we're comparing. In this case, we're comparing cases, okay, we're comparing cases and rolls of paper towels. Those are the two quantities, okay? Two quantities are proportional if one is always constant to the other. Constant to the other. So the rule is, okay, y equals kx. All right. Now, that will make sense, okay, because right now this is the x column and this is the y column, and we are multiplying it times the constant. 12 is called the constant. All right, so constant. Let's talk about constant. So your constant is the fixed multiplier. Fixed multiplier all right, which is k, equals k, and it is also called the unit rate. Okay, and the unit rate, okay, they use these terms interchangeably. Is y per 1x. Remember, when you see per, that means divide. So also known as y divided by x. So the constant equals y divided by x, which you're going to see a lot. And is also the place on the graph where x equals 1. Okay. Okay. Now just keep in mind you're transitioning from looking at a simple multiplication, like just one, let's say just one transaction, where 1 times 12 equals 12. Simple multiplication. Okay. Now you're looking at an entire group of data. That's what this table represents. Okay. An entire table of data. I can't draw that line. That circle too good. I probably could put a box around it. Okay. So now you're looking at a total group of data. Okay. You're looking at the total group of data. All right. That's why we're looking at the first basic form of relationship, proportional relationship. Okay. For a graph to have, or for two quantities that have a proportional relationship, there has to be the same constant, and the equation is y equals kx. And the other thing is that it has to start at the origin. Okay. And you know from graphing, the origin is 0, 0. Is 0, 0. All right. So copy that in your notes the best way you can. And the best way that I can think of to kind of make sense of this transition is you got to keep in mind that we're basically moving to a graph. So you're moving from a simple multiplication, 1 times 12 equals 12. You're looking at the entire group of data. So now you have variables and equations, the y, the k, and the x. So now you're moving into variables, you're moving into equations, but the real next level of this is the graph. And I think it makes more sense with the graph. So we're going to sketch a graph. It doesn't have to be perfect. Okay. You don't have to sketch it. All right. But this kind of makes it a little bit more clear, hopefully. Let me change the color. All right. So right here would be our origin, 0, 0 at the corner. Okay. And we can, I can make that a little bit neater. So 0, 0. All right, and let's look at the intervals. So down here on the bottom, we're going to do 2, 4, 6, 8, 10. All right. Don't have to be perfect. You're just trying to get the concept. And over here, we're going to do 20, 40, 60, 80, 100, and 1 20. All right. All right. So to make this simple, it would be kind of hard to draw these, okay, these points. All right. Because like if I wanted to do X is 1, 1 is going to be, let me change colors. So like, don't do this, but like right here, we would guesstimate that 112 is around here. And then 336 is something like this. Because say this is 3 and say this is 1. Okay? Okay, but do you understand what I'm saying? Because we're going up. It's basically like you're counting by 12. So 1 times 12, 12 is here. 2 times 12 is 24, which would be about here. 3 times 12 is 36. That would be around here. 4 times 12 is 48. So that would be around here somewhere. So basically, you're expanding from doing independent multiplication, so to speak. And now you're taking that and putting those on a table. So this is basically a graph of your 12 times tables. Okay, so you're used to doing multiplications on your paper. Now you're turning it into a table that's related to the real world. So in this case, we're talking about cases and rolls of toilet paper. Okay, so now you've added a story to your multiplications, and then ultimately you're going to create a visual representation of that. Okay, so this is a major shift in your thinking. This is okay, so it's going to take some time. Okay, but what I was going to say is what we can do is when you're drawing a line, all you need is 2 points, and then you can connect the dots. Okay, so if I'm looking at this table, the easiest 2 points on here, in my opinion, would be the 10 and the 120, because that is going to be about here, and that is going to be on the lines because it's a 10 here and a 120. Okay, the next one might be the 5 and the 60 because I got a 60 here. I don't have a 5, but I can guess it's going to be about here between the 4 and the 6. Okay, and then I can connect these lines. It's not perfect, but we're getting the idea. Okay, so it's going to be something like this. Now I have like a straight line, and now I can use this visual to fill in the rest of the data. So I can now say the 12 is about here. Okay, the 24 is about here. The 36 is about here. The 48 is going to be about here. And not only that, now that I'm thinking in an abstract way, I can like expand past the 10. Ooh, that arrow is shaky. Okay. And I can expand my y axis. Remember, this is my y axis. And this is my x axis. Okay. So now I can expand in those numbers indefinitely if I wanted to. Okay. And real quick, why is this important? Because think about it. You know, if you're just at the level of thinking where all you can do is just simple transactions, that's one thing. But now if you start looking at patterns from a bigger perspective, okay, like who needs to look at data like this? Like now I'm the person who's stocking the shelves at the store because I need to know how many cases I got to pull out. Okay, maybe I work at a restaurant and I'm the chef, and I need to go to the store and buy enough food for the night. You know what I'm saying? So now I have to be able to think in larger terms. Okay, and then what if I own a bunch of restaurants? Okay, so now I need bigger numbers. I need to be able to think at a larger level of problem. What I'm saying is the the larger the problems you can solve, the more money you usually get paid. Not always, but for the most part in the real world. Okay, so that's why you make this shift from thinking from basic transactions to thinking in terms of real world situations on a broader term. So that's the foundation I want to plant. So this as we move forward. So when I say constant, this line represents the constant. Okay, this blue line represents the constants because everything on X gets multiplied times 12. Everything on X gets multiplied times, in this case, 12, which is the constant. And that will give you the y-axis. So 1 times down here, 1 times 12 will give me 12 on this y-axis. 3 on the x-axis times 12 will give me 36 on the y-axis. That's kind of why it's written like this. Because anything we multiply times the constant, which in this case is 12, will give us our y-axis output. Okay? All right. So that's the best I could do. So put all that in your notes. Pause as necessary. Keep it moving. I'm gonna move a little bit fast through the rest of this because I just wanted to put these foundational ideas in your brain, and we'll talk about it more. We can always pause it. I'm moving forward. All right, so it looks like times 3. Okay, times 3 times 3. Okay, that's going to be 30. Now the thing is, when we're going this way, we're going to multiply times 3. But when we're going the opposite way, we're going to divide by 3, which is the same thing as times the reciprocal. Means the same thing. Dividing by 3 is the same thing as multiplying times 1/3. So in this case, let's just say multiply. Well, no, can't do that. Okay. Let's say we want to multiply this by 1/3. Okay, that's going to be 45 divided by 3, which is 15, which is the same thing as dividing by 3. Just want to make that clear. All right. How many cups of rice need to serve 45 people? Okay, 15. All right. Keeping it moving. All right, so here we can start looking at constant equals y divided by x. If this is our x and this is our y, okay, we can find out the constant equals our y, which is 3, divided by x, which equals, simplified to 1/2, or if that's confusing, you can just do it with a calculator. Yep, I tested it, make sure. 3 divided by 6 equals 0.5. Okay. So we would write that in our equation, y equals half x. Y equals half of x, or y equals 0.5x. Okay, so y right here equals half of x. So times half times half is 15, times half equals 20, and we'd have to divide this by 2, or times 2. All right, so in this case, let me try to explain this. So we have y equals half x. But here we want to know what x equals when y is 28. So now we got to flip the equation. So we're solving for x now. So we will multiply this times 2, or 2 over 1. If we do it on the left, we got to do it on the right. That's a 2 over 1. Okay, so this cancels, because if you multiply this out, that's going to be 2 over 2x, which is the same as 1x. And over here, you're going to get 2y. So x equals 2 times y. Okay, so over here, we have y, 2y equals x. So over here, we have x is going to equal y times 2. Okay, which equals 56. So this is times 2 going this way. These are times half going that way. All right, so just for clarification, I'm going to stop right here. We're going to work on the rest of the problems in class. If you got any questions, ask me in class. Peace.